Take down these few points related to introduction. Topic 1, Introduction to Data Structures. Take down these few points. First point, in computer science, comma, a data structure is a particular way of storing and organizing data. In a computer science, a data structure is a particular way of storing and organizing data. In a computer, storing and organizing data in a computer so that it can be used efficiently. Underline these two things, storing and organizing. Data in a computer so that it can be used efficiently. Next point. A data structure is an arrangement of data. In a computer's memory. A data structure is an arrangement of data in a computer's memory. Or even disk storage. Means the data structure can be created onto the memory, means primary memory. Disk storage means secondary memory. As an example, say printer requires a queue data structure to hold the jobs which are sent by the different users. For example, is a user 1 send one document. Let it be, consider a printer which is placed in networking. Consider a networking printer, right? I send job 1, he send job 2, means I send one document as a print, he sent second document, he sent third document. Printer is only one printer is available, not the 100 printers or 200 printers. A printer which is in networking, some 10 users sends the 10 documents as a printer, right? All these jobs are inserted inside the queue. First job is placed inside the queue, second document, third document, fourth document, fifth document. The printer takes the first document from the queue, process it. Printout come out. And the printer takes the second document from the queue, it is processed by the printer. So like this, the queue data structure is useful to arrange the data based upon first in, first out manner. Right? In these kinds of the situation, the stack should be used while writing programs related to device driver programs related to printer. An example of several common data structures. Next point. An example of several common data structures are the examples of several common data structures are arrays, linked list, queues, stacks, binary trees, and hash tables. Arrays, linked list, queues, stacks, binary trees, and hash tables. And hash tables. And hash tables. Next point. Different kinds of data structures. Different kinds of data structures are suited. Different kinds of data structures are suited to different kinds of applications. Are suited to different kinds of applications. Suited to different kinds of applications. And some are highly specialized. And some are highly specialized to specific tasks. And some are highly specialized to specific tasks. And some are highly specialized to specific tasks. Next point. For example, B trees are particularly well suited. B trees are particularly well suited of databases. Particularly well suited for implementation of databases. Particularly well suited for implementation of databases. So more detail we will see about B trees, how B trees are useful in creating indexing onto the databases. So I think if you learned DBMS, there we can see the importance of B tree, which is useful to create indexing onto the databases. Next, while compiler implementations usually use hash tables, while compiler implementations usually use hash tables, to look up identifiers. Hash tables, while compiler implementations usually use hash tables to look up identifiers. Hash tables to look up identifiers. So Turbo-C is a compiler application. It is using so many, that compiler internally using so many data structures. Right. Suppose as an example, here I calling the function add and passing two arguments AB, and it is an user defined function add. The arguments are, let it be x and y, and these are the sum statements. Let us watch here. This is a simple C program. Inside this, AB are known as actual arguments, actual parameters. What about this xy? Formal arguments. Formal arguments. Right. Actual arguments, formal arguments. So when I call this function, let it be A value is 10 and B value is 20. While this program is in execution, already all of you knows that whenever a function is invoked, the actual arguments are copied into formal arguments. A value is copied into X, B value is copied into Y. Internally, a stack data structure will be utilized to copy the values of actual arguments inside the formal arguments. What is the interface between copying actual into formal? Stack. So inside the main memory, there is one segment called stack segment, a permanent segment onto the RAM. So the RAM is divided into 4 segments: data segment, stack segment, program segment, extra segment. Like this, 4 main segments will be there. Heap segment. One of the segment is a stack segment. Whenever the data has to be organized, arranged based upon the last in first out principle, inside that RAM, that stack segment will be used. So while this program is running, how these actual arguments copied into formal arguments is, first of all, these actual arguments are copied into a stack data structure. Let us watch. It is a stack data structure. From left to right, these are pushed into the stack data structure. First A is pushed, next B value is pushed into the stack data structure. From this, these are popped. Which will be popped first? 20. What is the element inserted last? What is the argument inserted last? That will be deleted. Yes, these are copied into from right to left. Of course, 20 is copied, 20 is deleted first, that is placed into Y. Next 10 is deleted, that is placed into X. So that is the mechanism carried out. So the actual arguments are pushed into the stack from left to right, while copying the values are copied from right to left into the formal arguments. Like that. There are so many number of applications. Even while are compiling a Java program or C program or C++ program, in evaluating arithmetic expressions specifically, suppose say, that's all. Let it be, consider an arithmetic expression A plus B minus C. I forgot to write the right parenthesis. Left parenthesis I kept here, but I forgot to keep right parenthesis. So this kind of the statement is included in a Java program or C program or C++ program. Immediately compiler throws an error, the parenthesis matching error. Right parenthesis mismatching, parenthesis mismatching error it is. How the compiler will say some parenthesis, right parenthesis or left parenthesis is missing by using a stack data structure. Internally, whether that arithmetic expression is syntactically correct or incorrect, that is tested by the compiler by using a stack data structure. So compiler is a set of so many number of programs that is implemented by somebody, right? Stack, queue, so many data structures the compiler is using. Even we can see the coding. If you are having Turbo C compiler in our machine, clearly we can watch the coding. Why that compiler, TC compiler is having a stack program? Let us watch. Are you watching here? Already written code it is, stack.cpp. Push operation, pop operation. This is one of the program of the compiler. Stack is the implementation as a part of compiler program. Right? So this is the code the compiler uses for checking parenthesis matching. So like this compiler is using a huge number of data structures. Right? So later we will see all the kinds of the applications. Even if you want to find reverse of a given string, a stack can be used. Differently if you want to code as a regular practice using strrev function or by writing a for loop or something else. Right? Differently if you want to code that logic, yes, a stack can be used. Right? It is a stack. Let it be the string. Let it be for Rama. I want to find the reverse of the string. What I have to be pushed first? R, next character A, next character M, next character A. Delete it. Delete and display. Onto the user screen. First A is popped, that is displayed onto the screen. M is popped, displayed. A is popped and displayed. Next R is popped, that is displayed. Yes, onto the screen we will get this output. Reversed string. Use the stack data structure to implement these kinds of simple applications. And as well as in converting a decimal value into binary. What is a mathematical procedure of converting a decimal value into binary? We should divide the number with 2 and catch the reminders. Remainder is 0. 2 2s 4, remainder is 1. 2 1s 2, remainder is 0. 2 0 is 0, remainder. How we are listing these reminders? Top to bottom or bottom to top? Means what's the concept here? What is the last remainder you got that we should display first? What is the last remainder we got that we should display first? Yes? Why we cannot use stack here? Use stack. Don't use that arrays and nothing, some other variables or something else. Don't try to spend a time to frame the bigger formulas. To convert a decimal value into binary, don't try to construct complex things, complex expressions. Through simple, just write the pop function code and push function code and use it to find the this kind. See here, what we have to be do here it is, what is the first remainder we got that we have to be push into the stack. Next remainder, push into the stack. 1, 0. Right? In what order I am obtaining the reminders? In that order I am pushing one by one reminder. Pop it. What is the first reminder comes outside? 1. That is displayed. Next 0. Next 1. Next 0. Yes. This is the answer what you need. So like this, some of the applications I told, like this, thousands. In coding thousands of applications, we can use stacks, queues, linked list. Right? Arrays and linked list are the basic data structures in computer science, very fundamental data structures. That is, a stack can be implemented through array, through linked list. A queue can be through arrays, it is simple. Again, linked list means some sort of pointers concept, dynamic memory allocation related concept stuff is required. Right? Through arrays, it becomes so simple, the implementation becomes, but coding any data structure through arrays having a list of drawbacks. So my suggestion is always use linked list to implement a tree or a graph or a stack or a queue, anything. What is the coding you are doing? Do it through linked list only, not through arrays. Because arrays and linked list having, there are so many number of differences between arrays and linked list. So shortly we will see what are the differences between arrays and linked list, what are the benefits in linked list, what are the problems in arrays, and later onwards. Take down some other few points here. Just take down few points. By this I will conclude the class. Just there are two more points. Data structures are used in almost every program or software system. Data structures are used in almost every program or software system. Almost every program or software system. Next point, specific data structures are essential ingredients. Next point. Specific data structures are essential ingredients. Specific data structures are essential ingredients of many efficient algorithms. Specific data structures are essential ingredients of many efficient algorithms and make possible the management of huge amounts of the data. Management of huge amounts of data. Management of huge amounts of data, such as large databases, and internet indexing services and internet indexing services and internet indexing services. Next point, some formal design methods some formal design methods and programming languages. Some formal design methods and programming languages emphasize data structures rather than algorithms. Emphasize data structures rather than algorithms as the key organizing factor in software design. As the key organizing factor in software design. As the key organizing factor in software design. Key organizing factor in software design. Right, tomorrow I'll give the notes for the types of data structures. Right, a brief discussion also I will do on all kinds of the data structures under this. Types of data structures, linear and non-linear data structures, right.